Hello everybody, and welcome to another awesome tutorial. My name is Bradesko, and today we're going to be taking a look at how to create this amazing, well, I think it's pretty cool, Meteor effects. We're going to be using Houdini 19, and we're going to be rendering this out with Karma. We're going to be attaching a HIP file, the one that I'm using right here. Grab it and follow along. I hope you learned something valuable, and let's get started. So we have a few different elements here that we're going to be taking a look at how to create. We have the Meteor itself, which is just, a simple rock that we animated. And then we have some secondary elements that are, well, first off, we have the primary element, which is the main smoke that is being emitted from the main meteor, plus a few medium secondary smoke trails. And then we have some tiny ones, the tiny smoke trails that really help sell the scale of the effect. And you need some tiny ones. And then we have some super tiny ones that are literally just super tiny trails of just smoke being emitted from, really the smallest particles. And all together, it looks like this. I think it looks pretty cool. And also we can, let's see, clouds. We're gonna, when you put in some clouds, now it looks very cool, right? And with the new shading on the volumes with the ambient occlusion, I think this looks pretty cool, even without rendering anything. If we quickly take a look at how the render looks like, it's here on the right. Press render. Oh, I guess there was a preview from the render from before. Yeah, so that's kind of how it looks like. I think it's pretty cool. And yeah, Karma is pretty fast for these types of situations. But yeah, that's how it looks like when you render it with all the clouds and everything. And you can see Karma is doing a pretty good job at rendering everything at a decent speed, given that we have pretty much just volumes in the scene and they're overlapping each other quite a lot. All right, so let's get away from Karma for a second. I will make more space here. So this viewport is a bit bigger. And let's go into the shot creation. So these are the elements. I'm going to be showing you guys a special kind of bonus element that I was not using in the end, but they're like very cool sparks. Well, I think they look pretty cool, and you can use them for multiple different things. But if we go from the beginning, well, here are the three elements. These are the super tiny smoke trails, the medium smoke trails, and the big smoke trail, like so. And if we go from the beginning, we start with a very simple sphere. Sphere has a lot of polygons because we're going to be using a mountain on it. And also I'm UVing it, even though in the end I was not using materials, but I did UV it just in case if I was about to use a texture on it. And this is all static here, mind you, because we're going to be animating it soon. And then I'm going to be kind of showing you guys how I would deal this in a studio or production environment where, let's say, you get the animation already done, by the animators, and they would just give you a cache. And if you just have a cache, you would have to do a few workarounds that I'm going to show you soon. But so we create our mountain, which is literally just a simple mountain with a whirly cellular noise. It's hard to pronounce. And we have here an attribute swap that you can use if you want to. It just gives you a very cool lava/meteor shading. I didn't end up using it for the render because you don't see the meteor at all. It's completely covered in smoke. That's why I turned it off, but you can use it if you want to. Okay, next up, we do a VDB from polygons and a scatter inside. Mind you, here you have to switch to density. We do an attribute randomize on the normals because we're going to be copying a few grids. For that, you just put down a grid, you UV it. Again, not necessary. I just thought I'm going to be adding a different texture on the inside of the. So if I quickly show you, when we do an exploded view, I was thinking about doing a different material on the inside, and I didn't end up using it, but I UV'd this just in case. So we copy 2 points without using a random normal orientation. Everything is just going to be copied like this, and then the normals are going to be dictating the orientations. If you go here, inside sphere, and you do this, you're going to get a very random orientation. Put down a mountain to get your cutters, Boolean fracture, and that's it. You have a fractured thing, and I think it looks pretty cool. At least it works for our case. Next up, well, I guess I have an exploded view here. I'm going to create a rest, and I'm creating this before everything starts moving, and I'll show you why in a second. In here, all of these nodes are for animation. Now, I'm not going to be showing you guys how I animated this, but so this one was just to kind of rotate it. So this was the front of the meteor, and this is the back now. I did a transfer on the rotation, just $F, and you multiplied by 2. And this is going to be now using the timeline to animate this. Main move, literally just, I think, 2 keyframes. I don't know why I have more keyframes. They should be just 2. So it's in the Y and in the Z. These are the 2 most important ones anyway. And it's gonna go, whew, look at it. Look at it go. Like that. We look at it through the camera. There we go. Looks like that. And we're kind of following it, following the meteor going down. So that was the main move. Just diagonally animating it down and scaling it up because it was very tiny when I started modeling this. You can see it's not even a meter. And that can make a huge difference when you're creating volumes. Oh, I just saw this is still playing. But yeah, using a bigger scale, it's gonna come into play when you are doing simulations, because I usually try to do everything to scale without faking the scales too much, and that's gonna help you in the long run. So if you want a big meteor falling down, just make it big, even though this one is still quite small. All right, in this case, I was assembling everything, so that would just give me a few points. By a few, I mean 2,000 on just like separate pieces. And then I did a point velocity, which gives me a velocity vector of everything falling down, right? So now we know we have a velocity, we know how fast things are going and in what direction they are going. With this guy, I was creating a random group based on the point number. So if I read it for you guys, I'm gonna make it bigger. So if random point number plus a seed value, which is going to give me a seed. So if I quickly show you guys what this is even doing, I'm gonna blast it. So this is going to create a group called shards, and if we remove that group, we're going to see we get shards. And I'm just creating a random group based on the point number. If that point number is below a certain threshold, you are in the group called shards. So if I start changing the seed, you will see it's going to be changing the shards here for me. It's a bit annoying, this visualizer, but you can see it's going to be changing the seed. I'm going to go back to the seed that I had. With this one, I am creating a centroid, and you can see I'm plugging this into the second input here. And that is because and also keep in mind, I'm using detail to run over detail, which will just run over this code once. What I'm doing here is I'm creating an attribute called center, and then I'm using get bbox center on the 0 first. So it goes 0, 1, 2, 3 on the first, well, actually on the second input. And on that, this will create a position, and using that position, we create a point in space. Now, if we did the same thing here, it's going to still create that point, but it will also, and just put this to 0 now. So now it's still going to create a point. You can see we have 2099 points, and in this case, we have 2100. It still creates the points, but it's still running through all of the other points, and that's not what we want. We just want to just create one point, and based on the centroid. So that's why you would plug this in the second output, and it's gonna just output the point that was created. And now I'm gonna negate the position of this point. So we got our point, and this point is still moving based on, you know, our meteor. It's right here. You can see it's in the middle. And with this wrangle, we negate it. I pick the point attribute, the position attribute on the points from this single point that we created. And I say, what is your position? Do that, but the opposite. And that's going to negate it and put it back into our centroid. Well, sorry, back into the center in the world position. So why would we do something like that? It's because imagine if you don't do this transform, imagine creating all of your effects on something that is constantly moving through space, and then you emit points and you have to check it. If the collisions are working, then you go close and then scrub forward and then have to, you know, it's just a pain doing it like that. And it has some other economic reasons why you would do this. But one of the bigger ones is you just get more control and more speed. And, you know, obviously I could have done all of this before I did the animation here, because I was animating inside of Houdini directly, but usually you don't get the luxury of having this information here. You just get a cache that already has the animation baked in. So you would have to do something like this. Now, this is the simplest way of doing it. You can also try inverting the matrix, the transformation matrix and the rotational matrix. We're not going to cover that in this tutorial, but this is a simpler version that works in most cases. It's not going to negate the rotation in this case. And we actually do want rotation, because if we also negated the rotation and then we use this as a collider, you'll see our points are not going to be colliding in the right way. So we kind of do want rotation. We just want to negate the transformation. So that's what we're doing with these nodes here. All right, so now we have this back in the center and it's shattered and it's rotating. So I'm gonna split the shards between the shards and our main meteor. On the shards separately, I add some additional position transformations and noise to the position. And that will essentially give us this movement let me quickly preview this. this will essentially give us the movement of a meteor falling down. If you imagine like everything is falling now, and some of the pieces are kind of being left behind, some of them are staying a bit and lingering a bit longer. And you'll see I do a fix on this later where not everything becomes so flat here because it was kind of bugging me, but you can see some of them are staying and a lot of them are kind of falling behind because they're just lagging. Maybe they have lesser speed. And you can see it looks like this. Very cool. So how do you animate this? Because all of this is actually just animated in this node, right? So we have our position here, and this is just to push everything backwards a bit. You can see it's not doing much. It's just pushing everything backwards. And now we want to rotate and transform all of these shards. Well, what we do is we can create a turbulent noise and just add it to our position. It's a 3D noise and Perlin, and let's just increase the amplitude. So that's pretty much what I was doing. But because this is moving all the time and it's rotating, every time the position shifts, every time we get this rotation, we're going to be getting a different transform, different position. That's why this turbulent noise is always switching the offset like that. And if you remember before, way back here, maybe not way back, but here I did a rest position. And that's the reason I did it, because I don't want any rotation happening or transformations. So if we plug in our rest, and it's a vector, and instead of using this position for our turbulent noise, we just use this one, you will see this is going to work now. So now we can use, you can change the frequency, you can do whatever to push these particles, and they're going to be kind of falling down like that. They still have a uniform kind of rotation set to them, and that we're going to fix that very soon. But that's going to give us in the ballpark. So now we want them to be moving as well up and down randomly. So we kind of need to imagine each point needs to have a value of between 0 and 1. So if you're 0, stay where you are. If you're 1, be pushed in some direction. And that direction, we calculated that direction before with our point velocity. We can use this vector and its direction to push it into the direction that it's actually falling from. So if we just do that and we say, well, just, we're adding position here. Where are we? What if we just add on top of that, just push it in the velocity that you're moving? And you can see we kind of did that by the velocity. Well, we can also normalize it just so everything stays here. You can see everything kind of moved by 1, but it is going to move in the direction that it's falling from. So if we pick this and multiply, actually I'm going to do a constant here. And now if I multiply this, we're just going to be multiplying our speed. So after we normalize it, it's 1, and now it's going to be 20, but it's going in the same direction. So that's exactly what we want. But we want to add a random value, like I said before, on each piece. Each piece needs a random value. So we're going to use a random node here based on the point number, because these are packed. So each point has a point number. If we put it into a random, it's going to output a value between 0 and 1. So we can put that into a fit. So this is our value. We know it's going to go between 0 and 1, and now it's still between 0 and 1. And we can push it here into this multiply. So now you can see what happened. Some of them moved more than the others because the ones that have 1 are going to be affected more, and the ones that have 0 are going to be affected less. And you can see that if I start stretching, we're going to get each point is going to be getting a random push based on this velocity. And that's pretty much how I did that push. The only other thing that I did was you animate these two values. So this is the velocity, and you can just do this and you animate it. Oh, it's saving the scene, and you animate it going back, right? And you could just extend this. And now if you look at it with our Meteor and we do a little play blast here, they're going to be kind of lagging behind, and it's going to give you a feeling that everything is flying through the air and they have a different mass, a different speed, and that's going to give life to our effect like that. I think this one is even better than the one that I did. Yeah, I think that's look right. Yeah, it looks good. All right, so now everything was still quite everything works, all right, at this point, but they're still kind of rotating at the same time. So I added another transformation, which is I covered this more extensively in the One Punch Man tutorial on how to do this. So check that out because I was explaining this in a lot more detail there. But essentially we are doing a rotation, a random rotation on each point, and we are using this angle something weird is happening here. Yeah, that's like I think that's a Houdini bug right now that's happening, but you can see it's doing a random rotation on each point, and that's kind of what you want. And you can animate this. We put $by2. I think that you can kind of see now everything's going to be rotating. Maybe let's exaggerate it. Yeah, too much. By 1. Too much. You can see what I'm trying to do here. I'll go back to my value, which I think was animated before. Maybe it wasn't. Maybe I was, yeah, I think what I was doing is, you can see now everything is kind of, you can see they all have the same direction because of this transform. And with this, I just changed the rotations slightly here, so it feels more random. All right, I hope that wasn't too confusing. And there was a little bug happening here with Houdini, but let's move on. So we have our main meteor, and now we have our shards. All right. I unpack everything here, and I transfer the velocity because we're gonna need it. We're gonna be emitting our smoke. Here, I'm deleting the small parts because I only want to keep the big to medium parts and then use the small parts on the second sim. I don't want to sim everything in one place. So you can see I have 3 different simulations here. They're all pretty much the same in terms of setup, but they have different scales, so they need a bit of a different treatment to them. All right, I cache it out. We have this happening right here, and I blast everything here again because remember before I said I wasn't absolutely happy with how these shards were looking. Here they kind of became a bit flat. You can see they're forming a line. So what I did was I added another stretch, which is that same node that we created here. and I just added even more stretching, and I removed the big piece here. All right, so now it feels more organic, and they're more stretchy as before. Before they were kind of forming a line, and this was pushing everything a bit more. All right, but that was just like a side thing that I did, and you could have done this here before you start going into this tree. And then I merge everything back. I'm gonna do a little scatter here. Just scattering. What was I doing? Never mind. Scattering color with attribute noise, you get a color, and then removing some points just so we get a bit more randomized emission, but this part is not super necessary. Then we do a pop. Oops. Do a pop sim like so. And because we still have, everything is still in place. Everything has its velocity. So the points are just going to be pushing into the velocity where everything is flying towards. So you can see now how this becomes more practical, right? That we have everything set in place here before we start doing any type of simulations. And this pop network is a very simple one. It literally has nothing. Everything is set to the defaults, except I was using a different interpolation source. Just so if I set this to negative, to none, we're going to be getting some stepping in the sourcing. And that's happening because, we would need more substeps and everything, and this just fix it. So I think it was set to negative, and I'm using the point velocity because we do have velocity in this case, and it's just going to be filling in the gaps here for our emitter. You can see I'm using a negative velocity here and just a bit of variance, just so it becomes a bit more random and more fuzzy at the edges. And then another pop source, pop force with the amplitude set to 50. All right. After we have that, we cache it out, and you can see I'm caching 3 substeps, and I'm using 3 substeps. And that's kind of important for our simulation. So this is the emitter we're going to be using. Now, the reason why we do emitters like this for a simulation like this, well, it's going to pop out like this, is because if you don't do this, you're going to get serious stepping issues in your sim. So for instance, if we don't do this, and we just use our points here, let's see, I'm going to go a bit off-road. Just plug in here. Never mind this, I'll explain this in a second. Just see if everything still works. Like this. Just trying to prove a point. So if you don't do yeah, it's a bit slow. If we don't do the particle simulation, and in this case, I'm also using 3 substeps here. So let's go to 1 substep. It's going to be a bit faster. But yeah, without using the particle simulation, we're going to be getting stepping in the sim. And you can see that stepping happening quite intensely right here. And that's the #1 issue that we usually face when we have fast moving objects. And that's the best and the easiest solution to fix it. So what we have to do when we get stepping like this, we have to, on this frame, our emitter still has to be on this frame and maybe even on this frame. And in our case, it's just here. So every frame that we do, it's going to be emitting from that frame. And without any substeps in between, that's what it's going to be doing. It's just going to be emitting on each frame. So the idea is, what if we, instead of just using this frame, we use a source that is longer. So now, even though it's still moving, from one frame to the other, it's filling in all of the other detail. And that's how we get rid of the stepping. And that's why we're doing this. Now, like I said, keep in mind we're using 3 substeps. Now, what does that mean? If you go here on your Houdini here, you can see we are right now using integer frame values, which means that we are moving per frame. With every frame, we go forward 1 frame and backwards by 1 frame. If we use the integer frame values, we're going to be able to access the in-between frames. And you can see we have in-between frames of our sim. And that is because we cached them. We cached 3 in-between substeps. And if you don't do this, if you only cache 1 substep, your sim will still be stepping. I can quickly show you on this example. So if you don't have the in-between frames, you can see even though the numbers are changing here, you can see they're changing, but nothing is happening. It's still going to wait until it goes from 1 frame to the other. And that is because we have our substeps set to 1. And that is quite important when you're doing simulations. More important than you think. All right, so we are back with our points here. They're all nice and simmed. Now what? You could sim your volumes like this. You could. And use the velocity to push all of your volumes backwards. But that will give you a kind of a fake looking simulation. You can do it in some cases, it's going to work. But in this case, we need these particles to be moving through space. And that's honestly the only way that I can think of to get a realistic simulation. You cannot just fake everything like we were doing up to this point. So what we have to do is get our point back. Remember that point we were creating? The point that was created right here. Here, that single point. We take it. So we do an object merge here. And we take that point. And we go down, down, down. And plug it here. And what we do the inverse of what we did before. Remember before we did minus p. Now we just say, just use that position. Use the position of this point. And this position of this point is now my position. And that will put our points from here. There they are in the center. And it's going to push them back to where the meteor was originally. It's like magic. It's going to work like so. And now we can use that to sim. Before we sim, we need to create our Pyro source. In this case, I'm using velocity, temperature, and density on this side. On the other side, I am calling, so removing some points based on the age. So I say if age is higher than this threshold, remove the points. And that's what I'm doing. You can see here. And the age attribute is being written by our pop network here. Out of it, when you get your simulation, you get the age attribute. Here it is. And so this side is just going to be our flame. And this side is going to be pretty much our density and temperature and velocity. So here, I'm just creating a burn field that in Pyro, you use burn to create the flame field. And I am, just creating a burn field here with a volume rasterize. And here on this side, I am creating the same thing, but just using the density, temperature, and velocity. Merging it like so, and that goes into our Pyro solver. Now, one other step that I did here is I have these pieces that are flying. We did the same trick here. Grab that point, did the position. So now everything is flying again. I did a time blend. And the time blend is gonna help. You can see. Although I think the time blend was not needed in this case because we were transforming this you're transforming this geometry. But the time blend usually, if you don't have substeps saved, in this case we do, you can see everything is moving. But if you don't, I usually just out of precaution, I add a time blend. So time blend here, and I just time blend the position in this case, just to be sure that we do have those in between substeps, because they are, again, quite important. I calculated the velocity here for some reason again, or actually, yes, I was adding a curl noise, so you can see what this is going to do. And by the way, if I wasn't clear, this side is being used for collision. So plug that back into collision. The velocity, without this, velocity was very straight and boring. It was just falling down. If we add this, it's going to add some of that curl noise goodness happening here. And we want that to be on our collision, because with collision, once you do this, you can turn it into a VDB and you name it collision. And you can also create a velocity VDB here. And we're going to be using both. All right. So another point that I want to take, that I want to make with those substeps, if we go back, and we don't have substeps on, let's say you cache this, right? You cache it with one substep. You make that mistake, that final mistake. You cache this with one substep. Where are we? So we have this, you cache it. We do a sim. And you can see in the beginning, we still have some issues with the substepping, but then later when this extends to its full potential, like here, with the issue is going to be gone. Also, mind you, I am starting with -30 of pre-roll time. And that is exactly for those reasons. So we have some pre-roll before our shot begins. We already have a trail happening. Okay, so. And I think to illustrate this better, I will, put the global substep back to 3. All right, so I will do a sim here, just one sim. It's gonna take some time, so I'll probably speed this up for you guys. All right, so we have a sim, and you can see we are still getting that substepping happening. And that is partially due to our collision not having proper substeps. So even though we are using 3 global substeps here, if our collision is cached with only 3, it doesn't matter, because it doesn't have that information. So now if we don't cache this, this will have all the substeps that we need. You can also go here and just cache this with more substeps, but in this case, I'll just bypass this and do another sim. And you will see that here, if you look closely here, you can still see the substepping happening. And hopefully, with the new collision now in, that will be gone. So where are we? You can see it's already changing. Look at here. See that? See how smooth it is when it overrides the previous preview, like that. So that's quite smooth now. So that's how we want it to be. And you can see if you don't do this properly, if you don't do this setup properly, you're going to be in a world of pain, because you will be hitting yourself on the head. Why is this so slow? Why am I getting all the steppiness? And that's how you fix it. All right, so we cache this out. We do a little pyro bake. I'm using flame and flame for everything, for the scattering and for the fire. Let's punch this forward. And here we go. It's pretty cool. I like it. Looks pretty good. We are getting nice details here. I will not be covering the pyro setup because it was very basic. Just sourcing everything in. And like I said, please do download the HIP file and follow along with the file. It's going to be much easier. The only thing that here I am setting is SDF plus volume velocity. So now we are using that volume velocity. I can quickly show you if I go here, so it's a bit faster. Collision, let's put this to 5. You will see this is going to start exploding now. Now our collisions are pushing in a lot of velocity in the beginning. And it just creates that bubbly effect. And it also creates, well, I like the trail that it does because it kind of creates more interaction and almost like it creates a wind field. Not a wind field, but a wind. Yeah, like a wind. Yeah, it's a bit too much. But yeah, it creates a way of the collision is dragging the volumes behind it a bit better in some cases. But it's, yeah, this is just too much. It's just to illustrate that what this is doing. You can see how this is pushing now everything. But yeah, this was set to 0.7. You just use it sparingly. All right, put that back. For shapes, I was just using some basic turbulence and disturbance using the speed field. I really like this guiding that you can turn on. Actually, no, where is it? They changed this just a tiny bit. Here it is, speed. Speed back to 1, just to illustrate. But the speed field is going to give you a very nice indicator of how the speed field looks like. And I really, really dig this. It's very cool because it gives you a way of finding out the values that you need for your speed. So you can see now, if you go to, where was it? Speed. You can see, all right, everything that is red is going to be super affected. Everything that is not red is not going to be affected. If you put this to 0 and maybe this to 1, everything is moving super fast. So now your disturbance is going to be applied everywhere. But if you put this to 3 and this to 15, you're going to be only applying the turbulence on the hot areas. And now you can visualize this. Before, you would have to create your own visualizers, which would require you to go inside here. And now this is a whole mess. And now we go even more and you're like, oh my God. And now they did this here for you. It's very convenient. And now you can use those numbers to know where to put your values here. I put it to 10 just to be even more safe. I did the same for turbulence. And that's pretty much it. That's the main setup. The small smoke trails have the exact same setup. Everything is the same. The only caveat here is because I really want these to be a lot smaller. If you actually was here. So if you put this to density, your burn field is going to be big because it's going to use density as the coverage attribute, and you don't want that. If you're going to do this, your trails are going to be quite big again, and you can see the difference. This is how thin you want them to be, and if you don't put this to burn, they're going to be way too big. You can see how thin they are now. So this is a caveat. And the other thing are the super tiny ones. And the super tiny ones are same setup. So we have the tiny ones, cache them out. I delete the big ones in the middle, that stretchy thingy. I removed quite a lot of them randomly using this, the wrangle. So we have a lot less of them. Unpack, scatter points, so they have a lot of points on them. And then I did a pop sim. Pop sim is the same as the other ones. That's why there's not a lot to say about it. Pop sim. Look at them go. So we have them doing their trailing, push them back so they're flying, do a VDB. So here we do a volume from particles and a VDB. So the VDB you name to density, and this is where you put your voxel size, and then volume rasterize particles, we are rasterizing just the density, and we are creating density. So it's going to be using points and p-scale, which you can set here. And also I was adding velocity blur because in some cases they were still a bit steppy. If you add velocity blur, it's going to kind of blend and smooth everything. And for these really tiny ones, that was working quite fine. You cache them out. All right, very cool. So that's the main setup. Now I did want to show you another kind of bonus setup, and that was happening here. I didn't end up using it, but you can, if you want to, you can make it work. So we have our rock here again in the middle. We did all the same tricks here with the points, pushing it back. Here I made it a bit bigger and I put it into level. So before it was following down like this diagonally, and I put it back into kind of water level horizontal position. Then another point, although this was not super necessary, and I copied my emitter to it. Now my emitter looks like this. It's not much, but what it is it's a sphere that has so first off we create normals on the points, and then we go here, and here I just create the velocity. So you can see I'm subtracting. Let me just first pluck all of this out. So you can create a new vector by subtracting your points minus a point. You subtract them, you create a direction. That point is this. This is the point that I'm using. So whatever I do with this point, you can see my direction is going to be changing. Also, if I go further, it's going to create a higher amplitude because the subtraction values become bigger. So I put it right here at the beginning of our sphere. The way I'm controlling this is when you do a subtract and then you promote your parameter, you can now right now this is just a single value, but you can go here, change this to a vector. And when you change this to a vector, you get X, Y, Z. Now on this point, you can copy paste this parameter, which is its position, and you paste it here. Now this point here, this position here is gonna be this point, the position of this point. I hope that makes sense. And then you subtract everything and you get this. So now we have our direction vector, but you always want to do some randomness to it. So if you have a turbulence, and I will show you right away why we are even doing this and how does this look. So we have our turbulence. The color looks like this, and everything that is black is going to be 0, everything that's white is going to be 1, and then everything in between is going to give you in between values. So if you use this, if we look at our vector and we say, well, multiply everything by this map. So everything that is white, you just stay as you are. If you're dark, like this patch, become negative, and that will give you some variation between your velocity. And I did exactly that. So if you plug this into your velocity, you can see now how this is going to be corresponding to your map. And that will give you some randomness. I'm pushing it through a ramp because here outside, once you use that ramp, you can control your noise. And based on that noise, you're going to be getting different vectors. Well, different vector randomization, at least. All right, so I add some kernel noise. I always like adding kernel noise. It looks like this, very fuzzy and nice. In this case, I was just creating a mask, and honestly, you don't have to do this. So I'll skip this part, but you don't have to do it because I was clipping everything anyway. So I was clipping. So before I clipped, I removed everything based on the color, and then I clipped it in the back and in the front. So this is our emitter that we're going to use for our sparks. So I copy pasted to where my centroid is of the meteor. So it's in front, scatter points, and now we're going to do a particle sim. It looks like this. I feel like I moved some values. Let me quickly find them. All right, so I did find the issue was here, this multiply. I forgot to plug it in. It's like this. So what happened was, if I don't have that plugged in, the sparks are not really going to be flying outwards. They're going to be just flying straight like this. And what we want is that outward motion where something happens. Let me find my words. So if you have this meteor and this is flying very fast, you kind of want your particles to be flying like this, right? So that will make it look like it's flying fast, and it's going to have some weight and velocity to it. So that was the whole point why we were even creating this vector, was to have everything from the center going outwards. And if we don't plug this additional multiply, you can see it now clearly, how everything is coming from the center and it's going outwards. All right, so now if we do the sim, you can see this is the old one before the fix. And now everything is going to be flying away from our sphere. And now you actually get a sense of speed. You get that cone happening here. All right, so now we have this cone and it looks pretty cool. Once you add sparks on it, let me quickly show you how that looks like. It looks like this and it works. It's fun. But what I added as another bonus, you can use an RBD object here and just plug in your meteor that's kind of rotating like this. And once you do that, let's do a quick flipbook. It's a bit annoying that it's not updating here. It only does that once you go into positive values. You can see that it creates a fluid-like motion to our particles, because now they're actually colliding with the meteor. And that you can also use that as another pass. Maybe you can rasterize the particles here and create a volume out of them. You can also just use this as an additional layer of sparks. You can do pretty much whatever you want. You can see they are actually colliding with the meteor, and they're colliding quite well. So you can also use this for sparks, and you can use that for your kind of volume speed fields. So that was another kind of tip. And the RBD object, you kind of need to reduce the bounce, because if you're high on bounce, it's gonna be freaking flying. So imagine it's gonna be going in the other direction. Looks pretty cool though. It's like a magical spell or something. But it's gonna be flying and then bouncing in the other direction. So this has to be very low. What if we increase the friction pile? Just want to see if they actually stop. They should be more contained now and actually stopping a bit more on the surface. But yeah, I think you guys can play with that. I'll just leave the friction for now. So yeah, that was kind of the bonus spark setup. And the sparks are very... this is kind of the default spark setup that I usually use. Houdini 19 does have its own spark system, and we're going to be covering that in a future tutorial. But for now, I just use the default one that I usually use, which is I remove... Here we are. I remove a bunch of points. Did a time warp here. The just to get the in-between points, and then retimed it so it's much faster. I guess we have to go here. So they're much faster. And then I'm using normal to copy our lines here. So if you don't do this, they're going to be pointing in the wrong direction. P-scale and color. P-scale is if you want to actually create a polywire out of them. Then I resample them and add some flow noise, which can be a bit more, because sparks are usually are not super straight. There you go. There's a cool little spark system. Whew. All right, that was quite a lot to cover. I hope you guys were able to follow, especially with that hip file. Now, the only last thing I did want to mention is how do you render this in Solaris and with Karma. So in order to render this, you have to, let's start with the smoke. You have to import your smoke using the SOP import. And it's really simple. You just literally go, because this is kind of a different context. So everything you have here, you kind of have to re-import back here. And it can be a bit tedious in the beginning, but once you have everything here, you can then again start transforming. You can use your wrangles here again. You can do a bunch of things, and it's going to stay in this context. And if you don't like this positioning, you can then just copy paste this again and kind of change it. And so it's almost like you copied all the assets again, and you can do an alternative version or alternative materials on this side. So it's actually quite handy once you get into it. So SOP import, and we do the volume, and you just plug it here, bam, and that's gonna work. And to make it super easy, you just merge it with a light. I know you're merging stuff with lights. It's a bit. Let's do a dome light, and this is gonna be rendering here already. And I did use a HDR here, so I'll use the same one. Like that. And if we make it more dramatic, you can see that's it. Super fast. It's very cool. So that's the kind of the concept here. So you plug in your smoke, you plug in all of your clouds. I'll include the cloud setup for you guys as well. You include your Meteor. Where is it? Lost it. This is a bit annoying. I'm still getting used to how to work around the viewport. Like some of the hotkeys are a bit different. So you have your Meteor. Shift R is to go inside and outside of your render. You plug in your lights. So we have a distant light somewhere here. You can go inside of your light and change it like you would before with Mantra. And then I have another spotlight and a dome light. They're very easy to control, nothing super fancy here, very simple. You just merge everything together. So once you merge it, it's actually going to be visible here in the graph. You can see you go to your scene graph, and if it's not merged, it's not going to be showing up here. So if you're up here, it doesn't know about it. If you're here, it's going to know about it. So you plug in your clouds here as well. You merge the clouds, and now you have this. You can use a light linker. In this case, I was using it just to add some extra. Well, actually, in the end, I didn't use it, but this Meteor HDR is then only affecting the Meteor. And I'm excluding, actually I was excluding this one, never mind. But yeah, you can include or exclude. You can see it has a checkbox or an X if you're including or excluding. Material library is where you create your materials. Here is the kind of the main smoke material. and you can change that here. And then you have to assign it. So for assigning, let's say this is our meteor here. Assign material, you drag your meteor here. And then for your materials, you go, if this is closed, you open it up, main, Meteor shader, plug it here. So now it's going to be linked. And then I imported my camera through a scene import cameras, or you can just create your cameras here as well. But I just find it easier to animate it outside in this case, and then you can bring it in here. And then you have your karma settings. You can play around with this, and Saber actually did a very extensive in-depth overview of how to use karma. So please check that one out. So once you have all of that, go here and then you shift R. It's going to render. Now it takes a while in this case to render, and I love this. Where is it? The Intel denoising. It's so good. In some cases, it's a bit too strong, but it's so good. And Saber shows you guys how to use that in comp later. So if you don't want the full effect, you can still kind of do it in post and kind of do half and half if you want to. But yeah, then this is the Meteor. So yeah, in this case, it's missing some of the elements. So you would just add them, like I showed you guys with the smoke. You just add everything, link the materials, and you're good to go. All right. I think that's it for this tutorial. It was a bit shorter than the other one, but I feel like we covered quite a lot again. For the clouds, clouds, very simple cloud setups. These were small ones just so it creates an illusion of speed. And then you have your bigger clouds like that. And I'll keep these setups in for you guys so you can play around and do some rendering on your own. But yeah, that's it. That's everything that we have for you guys today. I hope you enjoyed this tutorial. I hope you learned something new, and see you guys in the next one. All right, bye.